Hi, this is Tom, amateur radio call sign N8FDY. We're going to have another meter review. Today, it is the EEVBlog BM-235. And it's in Dave Jones's No BS packaging. It comes with the meter. It comes with probes. And they are flexible probes, like silicone, and they're gold plated. But this is a $140 meter off of Amazon. So that's partly why you're getting this. Good leads, and it's I think it's a good meter actually, but I am partial to Bryman. If Fluke didn't exist, Bryman would probably be my primary meters. So let's get on with some demonstration. As usual, there is a written review of this with a link in the description. And that goes to the written reviews on my GitHub site. Well, let's take a look at the features of this meter. It's UL listed in Canada and USA for safety. It's Cat 2, 1000 volts, Cat 3, 600 volts, and Cat 4, 300 volts rated. It's a 6,000 count meter. Has a basic DC accuracy of 0.3%. Plus or minus 2 in the least significant digit. It's true RMS. It has min, max, and average, which is the REC button on this meter. It has a hold, a relative or delta function. It has non-contact voltage detection with a high-low selection, so it'll detect low voltages. It has auto voltage low Z feature, which is used by electricians to find wires with phantom voltages. It can be used for variable frequency drive motors, which means it has a low pass filter on the AC. It has a K-type thermocouple for measuring temperature. It has the fuses accessible from the battery compartment, 240-hour battery life, has a 1-year warranty, and it comes with 2 AAA batteries. Now, one of the features that I've only seen in Bryman meters is it remembers where you were. So if you go to voltage, let's turn on the backlight. You'll notice it is in DC mode. If we hit select, it'll go to AC with the low pass filter. That's what that VFD means. If we turn it off, then we turn it back on, you'll see that with the backlight on, it's still in that same mode. It remembers. So we can change that again, and we'll go to AC without the VFD. And again, if we turn it off, turn it back on, it remembers. Turn the backlight back on, so it's still in AC without the filter. It does that with all the ranges. So that's a really cool feature. At least I thought it was cool till I started using it. Depending on the Fluke you use, you have to change the ranges because it always starts out in AC in many of the ranges, and you always have to switch it to DC. So I find myself doing that with these meters when you really don't have to. If you last time you used it in DC, it'll be in DC. Of course, me not thinking, I hit the button, thinking I'm putting it DC, and here I'm putting it at AC. So anyway, I think if you start out with Bryman meters and they work that way, then you'll get used to it. Let's try some voltages. 2.5005. shows as 2.500. 5.0009 shows as 5.001. 7.5016 shows as 7.50. 10.001 shows as 10.01. All the voltages I measured met the specifications as stated in the manual, and the accuracy specifications are about average for this group of meters. Well, I'm using my arbitrary waveform generator to generate an AC voltage, just to give you an idea of how it works. The Fluke 289 says I'm putting out 2.001 volts, and the Bryman says I'm 2.001. The AC volts I tested on this meter all met the manual specifications. The specifications for the 100 Hertz AC was average. The specifications for the millivolts AC at 60 Hertz was average. But the specifications for the 1 volt and above AC was above average for this group of meters. This is 0.89 microamps, and the meter reads 0.9 microamps. This is 9.21 microamps, and the meter reads 9.2 microamps. This is 99.2 microamps, and the meter reads 98.9 microamps. This is 131.8 microamps, and the meter reads 131.8. This is 1 milliamp, and the meter reads 1.00. This is 9.96 milliamps, and the meter reads 9.98. This is 99.4 milliamps, and the meter reads 99.3. All the currents I tested on this meter met the manual specifications. The specifications for AC current was above average for this group of meters, and the specifications for accuracy on the DC current was average for this group of meters. Well, now we're going to do some resistance values. Let's short together the leads, see what the lead resistance is. It says there's no lead resistance. That's suspicious. This is a 1.004 ohm resistor, and it reads 1.0. Here's a 10.007 resistor, and it reads as 10.0. Here's a 100.069 resistor, and it reads at 99.9. Here's a 1.0001 kilo ohm resistor, and this reads it as 0.999 kilo ohms. Here's a 10.002 kilo ohm resistor, and it reads it as 9.99 kilo ohms. Here is a 9.97 mega ohm resistor, and it reads as 9.98 mega ohms. This is a table of the resistance values I tested. Each value met the specifications in the manual. The accuracy specifications in the manual are average for the 60 kilo ohms, 600 kilo ohms, and 6 mega ohm range. For all the other ranges of resistance, the specifications were above average in this group of meters. Now we're going to measure some capacitors. The leads show a 0.02 nanofarad straight capacitance. So we're going to zero that out with the delta function. And the way you activate the delta function is to hold down the hold key for a second, and it'll switch to delta. Some meters call it relative mode. Here's a 10 picofarad capacitor, and the meter reads it as 0.01 nanofarad, which is technically 10 picofarads. Here is a 100 picofarad capacitor, which is a 0.1 nanofarad capacitor, which is what the meter is reading. Here's a 1.005 nanofarad capacitor, and the meter is reading 1.00. This is a 9.921 nanofarad capacitor, and it is reading 9.93. Here's a 99.51 nanofarad capacitor, and it reads 99.3 nanofarads. Here's 1.009 microfarads, and it reads 1012 nanofarads, which is really 1.012 microfarads. All the capacitance measurements I made met the specifications in the manual. The accuracy specifications in the manual are average for this group of meters. The low range that measured the 10 picofarad and 100 picofarad, the uncertainty values were high enough where it didn't really make a meaningful measurement. It would be very easy for almost any value to meet the specifications. But that's typical for a meter. It's very difficult for it to have accurate readings at the very low end of a scale. Here is a red LED, and it's dimly lit, but it does show the forward voltage. Here's a dimly lit yellow LED. The green LED does not light, but it does show the forward voltage. There's the Schottky diode. There's the small signal diode. There's the rectifier diode. Now we're going to test some continuity. Going to use the probe masters. Notice that the screen flashes besides the beep. And it is latched, and it's pretty quick. It's quick enough for me anyway. To get to the batteries, you have to remove the boot, and then one screw opens up the battery door. It's a captive screw, so you can't lose it. And lo and behold, the fuses are accessible from the battery compartment also, so you don't have to disassemble the meter. Here's a peek inside the meter, just so you can see what it looks like. Also, here's a close-up of the 400 milliamp fuse location and the 11 amp fuse location. Well, let's look at the pros and cons of this meter. Well, the good parts of this meter. It's under $150. It's third-party safety tested by UL. All measurements met the accuracy specifications of the manual. It had above-average accuracy specifications for AC volts, above-average accuracy specifications for AC milliamps and amps, above-average accuracy specifications for 600 ohms, 6 kiloohm, 6 megaohms, and 60 megaohm ranges, and the fuses are accessible from the battery compartment. And on top of all that, it has a 1-year warranty. Well, now for the not-so-good side. The capacitance readings below 1 nanofarad are not useful, but you're going to find a lot of meters are going to be that way. If you want to get accurate 1 nanofarad readings, you're going to have to get a dedicated LCR meter. And you have to send this overseas for warranty service. Well, to wrap up, this is a $140 meter. It is UL listed for Canada and the US. So it is a safe meter according to UL. It has a good backlight, stays on for a while. It has good accuracy figures. And it's a reputable company. And it comes with a 1-year warranty. The only drawback is you have to send it to overseas to get the warranty work. The manual is not included. You have to download it from the EEVBlog site. And it's the Bryman manual, but Dave Jones added parts and added comments and gave some good information. So this is the one of 2 meters in the 6,000 count meters that I consider the sweet spot. It may be over some people's budget, but I would say it's worth saving up for. So this one's $140 at Amazon. Of course, you can do has the Amazon return. And like I said, the warranty after the Amazon return time is covered by the manufacturer. So, but it is overseas. The manual says you send it to Taiwan, but it is EEVblogs, and I know that some people have sent them to Australia to get fixed. So either way, you're covered. But I have no problems with this meter, no reservations. If, like I said, if Fluke didn't exist, this is probably one of the meters I'd be using now. But this is Tom, N8FDY, saying 73, and take it easy.